So now we're going to talk about Spring Boot and the software patterns that it embodies. And we're going to talk about its overall design approach and patterns that it applies. And we'll see that there's a very sort of central pattern that is called convention over configuration, which is kind of a funny name. And we'll also talk about a few other patterns that are implemented by Spring Boot that you may or may not be familiar with, depending on what other courses you've taken at Vanderbilt. If you've taken the course at Vanderbilt on intermediate software design, which I think all the undergrads in the class have taken, then you're familiar with some of these other patterns. But there's lots of other patterns too. So the most crucial pattern to understand Spring and Spring Boot is something called convention over configuration. I always forget which comes first, but convention over configuration, which is kind of a funny phrase. And I strongly recommend you take a look at the link at the bottom of the slide to learn more about this. The goal here is to make it possible to create web apps by refining a general reusable blueprint. This is often sometimes called opinionated software platforms or software frameworks or software design. In other words, some people who have a lot of experience have opinions about how you should build these systems, and those opinions are baked into the way in which you can apply the components in the platform, in the Spring platform, in order to be able to build these applications. So this overall pattern, this convention over configuration pattern, is used by software frameworks like Spring to decrease the number of decisions that application developers who use the framework make without sacrificing flexibility. So it's really trying to give you a bunch of good default behaviors that will cover 80 to 90% of the design space. But for some situations, you don't always know exactly what you need to do. So you want to leave room for customization in order to be able to make the systems do what you need them to do, even if they don't support that capability right out of the box. So again, this is often known as opinionated defaults. You can read more about what this means up here, but basically it means that there's a bunch of strategies for improving the way that you build the systems, you test the systems, you deploy the systems, you integrate the systems, and so on and so forth. So let's talk about some of the elements in this convention over configuration pattern. So the first is reasonable defaults. For example, if there's a class in the overall model, the persistence model, the data model, if you will, that's called sales, then there will be a corresponding table in the database that Spring is aware of that will be called sales. Now, if you don't want to call it sales, you can change the name, but if you want to leave it with a reasonable default, pretty reasonable. If you have a class called sales, there should be a table in your database called sales that stores sales related information. So that's the reasonable defaults portion of this convention over configuration pattern. Another goal is to require only specifying the unconventional bits. In other words, things that diverge from the defaults. So if you want to call the table product sales instead of sales, there's a way to do that. It just isn't the default. And this is a time-honored way of building extensible software. You try to make it easy to do the normal things correctly. You try to make it hard to do things incorrectly, but you don't make it impossible to do things that weren't anticipated with the normal way, with the conventional way of doing things. Another goal is to try to eliminate distractions. So what does that really mean? Well, in particular, there's no real need for people in modern software environments, especially networked or distributed computing environments, to have to know how to program low-level networking details directly. You should be able to leverage declarative configuration mechanisms that allow you to emphasize what you want to do, and you leave it up to the implementation to figure out how to do it. And I always like to represent that dichotomy with an iceberg where the visible part is the what part, that's the part you care about, and the implementation part or the how is kind of invisible to you, lurking under the surface and hopefully safely out of your way so you don't run into the underneath part and end up causing yourself to sink like the Titanic. So don't need to have to worry about low-level programming details. This is also true for concurrency as well. In addition, we also want to have the infrastructure manage the event loops using inversion of control, like we talked about before. So again, try to focus more on business application logic and less on infrastructure plumbing with respect to things like memory management, concurrency, message passing, core mapping, different types of encoding, protocols, all that kind of stuff is hidden from you. And then another theme here is to reduce the number of decisions that you have to make. So we want to be able to, for example, auto-wire fields to their implementations automatically using dependency injection rather than requiring developers to have to write code to do that explicitly, which just tends to require more code writing, more code maintenance, more code documentation, and more opportunities for hard coding yourself to the point where it's difficult to make changes as requirements evolve or your underlying environment is going to change. There's also a whole slew of other patterns that Spring Boot implements. These are covered in many other great books and online resources. I've written a whole series of books on these topics. My friends and colleagues have written a whole series of books on these topics, and these would include patterns like broker and proxy, publisher subscriber, factory method, component configurator, model view controller, resource pool, you name it. There's all kinds of stuff. Some of these patterns you would be familiar with if you took the intermediate software design course at Vanderbilt. Others of these patterns would be things that you would probably have to read other literature like the books I've written or other material you can find online. So just always be aware that looking at things more holistically in the form of patterns not only teaches you a bunch of principles that you can apply that will save you time, but it also makes it easier when you transition to different environments beyond Spring or beyond Java. Because even though the languages may be different, the syntax may be different, the APIs may be different, oftentimes the underlying patterns are very, very similar. Okay, so that is the end of our overview of Spring Boot software patterns.